Okay, so in this lesson, we're going to talk about drawing scatter plots and best fitting lines. And the essential question is, how are scatter plots and regression lines or best fitting lines used to analyze data? So first things first, let's talk about what a scatter plot is. A scatter plot is just a graph that contains a set of points, a set of data pairs that contain an independent variable and a dependent variable. We also have to talk about this idea of correlation. If you have, and correlation is just what's the connection between the data pairs. If you have a positive correlation, the y tends to increase as x increases. And then if you have a negative correlation, the y value or the dependent variable tends to decrease as x or the independent variable increases. We also will talk about what's called the correlation coefficient, and that is a number, we call it R, and it will fall anywhere in the -1 to 1 range, and it measures how well a line fits a set of data pairs. So we have some graphs of correlation coefficient examples. If you have a correlation coefficient of R equals 1, that is a perfectly linear positive correlation. It doesn't mean anything about the slope. It just means that as x increases, y exactly increases at a steady rate with it. You could have a correlation coefficient of -1, where r equals -1, and that's the same, but as x increases, y perfectly linearly decreases. You can have a correlation coefficient of 0, and that's where the data points are just kind of spread all over. There really doesn't appear to be a pattern as x increases. You can't really say if y is increasing, decreasing. So if you can't see a pattern at all, like in this middle graph where it says r equals 0, then there is no connection. There does not appear to be a relationship with y and x as x is increasing. If you have an R value that's in between 0 and 1, that means there's a positive connection or a positive relationship as x increases, y increases also. The closer the points are together, like in this example here, the closer that number should be to 1. And then the more spread out the data is, as in this example here, it's still trending in the positive direction, but because it's not as close to linear as the previous example, this would be closer to 0. And then for these next two examples, the correlation coefficient for this first example, it should be a negative number because it's decreasing, but it should be closer to -1 because it's not perfectly linear, but it's pretty close to linear. And then for the last example, I can see an overall trend that as x is increasing, y is decreasing, but it's not as linear as the example before it. So this should be a negative correlation coefficient, but it should be closer to 0 than it is to -1. So we're going to use the graphing calculator to do the scatter plot for us and to calculate the regression line. So for our example, we have this table listed here. It gives the number of people Y who attended the first 7 football games X of the season, and then our job is going to be to use that calculator to create the scatter plot and to calculate the regression line. So I am going to open up our graphing calculator, and I've already run through the diagnostics piece, so if you've done that once, great, but if you opened up a new calculator, remember you need to make sure that your diagnostics is turned on. So scroll all the way down until you get to diagnostics. You want diagnostics on. Enter our information, so stat and edit. I've left information in here from the last example that I did. So if you ever have that where you need to clear your list, if you hit clear a bunch of times, it's not going to work that well. So scroll up to where it says L2, hit clear, and then hit enter. And then same thing here, you have to scroll up and highlight where it says L1, then hit clear, and then you have to hit enter. So I'm going to input the information from the previous slide. I took a picture of it so I wouldn't forget about it. And then once you have your list entered, scroll over to L2 and input that information. And always hit enter in between each new data point. And then when you're at the end, a good way to check and make sure you didn't miss anything is that you have the same number of data points in L1 as you do in L2. So now we're going to hit the graph button. And for me, this isn't showing up all that well because the window for my last example doesn't fit as well with the data that I just have, or that I just entered. So again, you want to go to Zoom. And you want to scroll down or hit the number 9 to zoom stat. So there's our scatter plot. That's part 1. Next, let's get the regression line. We're going to quit from here. We're going to hit stat. We're going to hit calc, and then you can either scroll down to number 4 or enter the number 4, hit enter a whole bunch of times, and then calculate. And now we have our regression line. And then again, you want to remember what A is, so you can either write it down or take a picture. We're going to substitute 27 in place of A. X is our variable, so we're going to leave that how it is. And then we're going to substitute 699 point, I'm going to go 429 in place of B. So it says approximate the best fitting line for the data. You can write down exactly the values that your calculator gave you. And then to see the graph on the calculator, all you have to do is hit the graph button. The last example we're going to look at, it says use the equation of the line to predict the number of people that will attend the 10th football game. So again, from the previous slide, X represented the game number. So X equals 10. So using our equation from the previous slide, we're going to substitute 10 in place of X. And then we'll simplify. We should get a value of 969.429. So because we're talking about people, you can round that to the nearest integer. So we could say about 969 people. All right, that is all for this lesson. Good luck and let us know if there's anything we can help you with.